What's going on? It's Miss Baldwin. I'm back for another day of learning about atomic structure. Do you miss me? You better miss me, because I miss y'all. Alright, here we go. Time to get started. We're going to start like we always do with our class creed. On the count of three. 1, 2, 3. Yes! I will learn today. I will do my best. I will give it all I've got to ensure my success. I am smart. I am bright. I can do anything. I'm an excellent student, and you know what that means. I work hard. I study, and my learning prevails. And when I am tested, I will pass the chemistry SOL. All right, if you don't have your interactive notebooks, I want you to take them out because you're going to need them. Okay, and you're going to need your boxes, so go ahead and grab those. I'm going to give you a couple seconds to get it, and we're going to get started. Get up now. Go get your boxes. 10, 9, 8, hurry up, 6, 7, 5, 4, 3, 2, and 1. Everybody should be back in their seats. You should have your interactive notebooks open, and you should already have your box with your scissors, your glue, and all that good stuff. All right, you should have gotten one of these, all right? It says cations, anions, and neutron madness. You should also have one of these that says average atomic mass and periodic table. Take a minute, make sure you have both, because you're going to need it. All right, here's what I want you to do. I want to start with cations and anions. Cations and anions is going on page 37. All right. Then we're going to put isotopes on page 38. That's right. We're gluing on both sides. Left side, cations and anions, page 37. Right side, page 38, isotopes. Okay. I'm going to give you a minute to win it. Start it now. Glue it. Go. We gluing in our notebooks. Y'all better be gluing. You gluing? Alright. Don't make me come over there. Alright now. I want to give a shout out to my block 1. Shout out to my block 3. Shout out to block 4. I love y'all. What up, Quay? What up, Tevin? What's going on? Since Baldwin. Alright. You glued it in? Alright, cool. Now, next thing you want to do, we're going on both sides. What sides? Both sides. Page 39 is going to be periodic table. Can you see it? Periodic table. Periodic table. And page 40 is going to be average atomic mass. Average atomic mass. All right, we're going on both sides. 39 is periodic table, and 40 is average atomic mass. I'll give you a minute to win it. Glue it now. Come on there, you gotta glue. Cut it out, cut it in half, glue it. Page 39 is periodic table. Page 40 is average atomic mass. Okay? Alright. And while you're doing that, I have this little thing out here I found in my kitchen. Can y'all see? Try to bring it out. It's a little Tupperware container. And I've got these little grapes. I could eat this one. Okay, good. You know I like fresh fruit. Alright, so you should have already glued in. I want you to turn back to page 37. On the top of 37, let me eat my grapefruit first. I want you to write homework. Okay? For homework, you're going to do that bottom table. You already know how to do it. We went over it yesterday. How to calculate protons, neutrons, and electrons if an atom is not neutral. That means if it has a little charge, like a +2 or -3, all right? So we're going to finish that for homework. And then for page 38, which should say isotopes, you want to write homework on that. I want you to complete that bottom table for homework too. So you're going to read and you're going to complete that. But what I want to do is take a minute to talk about neutrons. Everybody is all whoop-de-doo about protons and electrons. Protons identify the element, so they get mad play. Electrons are the ones causing all the charge, making things negative and making things positive. So everybody is all up in a ruckus about protons and electrons. Meanwhile, the neutrons get no play. That's not cool, and Baldwin's not cool with it. So this is what I want to do. I want to talk to y'all about the neutron, the underdog, the person that nobody really wants to talk about just because they neutral. That's not cool. So, neutrons, do you remember what they do? If not, turn back to page 34, they add weight. Okay? Where are neutrons? Where? Okay, good. They're in the nucleus. So, imagine that this little container is an atom. Okay? This is Mrs. Baldwin's atom. Okay? And in the atom, we're going to have protons, neutrons, and electrons. Now, we won't care about the electrons right now, but I'm going to fill my nucleus with some water. Okay? Just because, can y'all see me? All right, cool. Let me see, I'm going to come down like this. Just so y'all can see. I'm going to put it like this. Clearly, I'm in my kitchen. Excuse the mess. Can y'all see it? All right, cool. So now I have my nucleus, and it has some water in it. Now, neutrons add weight. Okay, neutrons add weight. So, can y'all see me? The average, here we go. The average atom needs a certain number of neutrons, all right, that it can accommodate. That means that it can have room for in the nucleus, all right? Kind of like a bus. Let's say a bus has 36 seats, so it has space for 36 people. Well, let's just say it's a really busy day and there's more than 36. Well, then we have a problem because we have more people than we have seats, and it could make the bus ride a little bit unstable. People might have to share seats or do other stuff like that. So let's just say I'm building an atom, and let's say my atom should hold, I don't know. Let's see how many it can hold. These are my neutrons. They're going to add weight. Okay? I'm going to put it down so you can see. So 1, 2. Let's get some more. Let's add 3. Uh-oh. Did you see it? 4. Look closely. 5. Oh, I wish you could see it. 6. Can you see that? Oh my goodness. 7. Okay. Now at 7, I'm experiencing some spillage. All right. So let me try 8, 9, 10. Oh my gosh. Do you see it? The water is spilling everywhere. Okay. And the same thing happens with atoms. Okay. Based upon the nucleus and the size and how much water was already in it, there's only a certain amount of space, of designated space, to comfortably fit these neutrons. But when you get neutrons that are extra added in, it makes it heavier. And it makes the atom much more unstable, all right? To the point where it can become radioactive. Did I just say that? Radioactive, okay? And radioactive just means it's really, really unstable, all right? So I hope this helped you understand what neutrons do. I bang with neutrons. Everybody's all going crazy over protons and electrons, but neutrons, they're where it's at. They add all of the weight to the atom. So if you have too many neutrons, you can get a radioactive isotope. It doesn't mean that it's a different element because the protons are going to be the same. And it doesn't mean that it's going to have a charge because it's not really affecting electrons because it's neutral. But if the atom is too heavy, if people are say someone is overweight, they might have more physical challenges or health deficiencies, all right? If there's not enough room on the bus, you may have to share a seat with someone because there's only enough space. And atoms work the same way. If I was an atom, I don't want just the right amount of space. I don't want too many people on my atom bus, right? So, Neutron Madness, you're going to read that. That's on page 38. You're going to do that for homework, okay? All right. Peace.